Hello again. This is Math 2231 coming to you from the College of DuPage. And the title of this video is A Proof that Differentiability Implies Continuity. As always, please be an attentive learner while watching these videos. So, the theorem that we're proving then is if f of x is differentiable at a point x equal a, then f of x is continuous at that point x equal a. Okay, so we start by assuming the if part is true, so f of x is differentiable. Now what that means is that the limit as x tends to a of f of x minus f of a all over x minus a is equal to f prime of a. We show that this is equivalent by a change of variable to the definition of derivative that we discussed in class, and it turns out this is exactly a form that we want to use to do this proof. So because f of x is differential at x equal a, we know this limit exists and is f prime of a, and that means this is a number. Okay, so now what we're going to do is we're going to look at f of x minus f of a. And what we're going to do is take this expression that we have here, f of x minus a over x minus a, and we're going to, and by the way, we have to assume that x does not equal a. And so what we have is x, this is not dividing by 0, so I'm really taking f of x minus f of a, and I'm multiplying by 1, because this is x minus a over x minus a. Now, by the limit properties, I know I can take the limit of both sides as x tends to a. And so here I have the limit as x tends to a of f of x minus f of a. And that's equal to the limit as x tends to 0 of this stuff. But here, since we know this limit exists and also the other limit exists, this limit is 0, the limit of the product is the product of the limits. Now, this first limit that I have right here, by assumption of differentiability, is just f prime of a. And this, because x is y equals f of x equal x is continuous at any point a, the limit as x tends to a of x minus a is in fact 0. So this limit that we've reached here then is f prime of a, whatever number that is, times 0 or 0. Hold that thought. So we know that's 0, but then, but the question is, so how does it help us prove that f of x is continuous at x equal a? Well, we're almost there. So let's look at this. The limit as x tends to a of f of x is actually equal to, and what I'm doing now is I'm adding 0 in a clever way. So I'm taking f of x and I'm adding f of a and subtracting f of a. And of course I can do that. So we just added 0. So now we're going to use the property of the limits on this. So the limit as x tends to a is the limit of this. We can take the limit of both sides since those were equal. And then this is the sum of the limits. So this is the limit as x tends to a of f of a plus the limit as x tends to a of f of x minus f of a. But we've just proven that this limit right here is 0. And so that means that this becomes 0. And so what we have then is that the limit as x tends to a of f of x is just the limit as x tends to a of f of a, which is just f of a. So in other words, the limit as x tends to a of f of x is equal to f of a. But this is exactly what it means for f of x to be continuous at a, and so we are done. Okay, as a final comment on this video then, What we now have seen is that differentiable functions are a proper subset of continuous functions. We've just shown that if you have a differentiable function, it is a continuous function. But in class, I showed you that y equals f of x equal the absolute value of x is not differentiable at 0, but it is continuous. So there are continuous functions that are not differentiable. So differentiable functions are a proper subset of continuous functions. And with the examples, the absolute value being chief among them, we have seen that abrupt changes in direction cause a function to not be differentiable. So what this all boils down to is that differentiability is a measure of the smoothness of a graph. This is an important concept in higher mathematics. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself. Self-care is important, and of each other. We're all in this together. God bless you all.